of b times x minus h plus k. Same as we did before. The h and the k are still the same shifts. The b value we still use to locate the period. So these are very similar in terms of what we've done with our other functions. So what I'd like to do is I would like to find the period. And I know since I'm dealing with tangent, PB is equal to pi. The b value here is just 1. So that means the period is 1 pi. Now, in terms of finding the asymptotes, we really do not care about a vertical shift. We absolutely care about the horizontal shift in terms of the location of those asymptotes. So for this, we would say that we have a horizontal shift to the right pi over 2. Okay, so remember our function family here. We had negative pi over 2, pi over 2, and that's where those asymptotes were. Now we're going to shift to the right pi over 2. So instead of this asymptote, we're going to now look here. And then if this is pi, we're going to have one here. So notice we're going to shift everything to the right, pi over 2. So if you're describing the asymptote, the location, this is going to be at x equals, it's a vertical line. I'm going to look at this one right here. At x equals 0 plus, what's the period? It's 1 pi. So plus pi k, where k is an integer. That means I see one here. This is at pi. I'll see one here at 2 pi. I'll see one here at negative pi. That's all that's telling me is all those pink asymptotes because I shifted to the right pi over 2. Now, we don't really need to write 0 plus pi k. We could just say pi k, and again, where k is an integer. So that would be the location of the asymptotes, okay? So that's where the location of the asymptotes are. Now, let's go ahead and talk about domain and range. The domain, again, what this is going to look like is something, and you don't have to graph it yet, but this is kind of what we're getting to, right? Which means I can plug in anything I want except for those asymptotes. Those are the issues. So we're going to say it's all real numbers where x is not equal to pi k, where k is an integer. So you're saying every single thing you can plug in except for those little troublemakers, right, where we get that undefined. And then our range, this is the boring one. It's going up to infinity and down to negative infinity for outputs. It's just all reals. That's it. So not much going on there for range for the outputs. All right, we're going to do just one more of these. So again, we're going to do where are the asymptotes located and the domain and the range. So let's first find the period. So the b value, this is our b value, is 2. So the period is just 1/2 pi instead of pi, just 1/2 pi. And then we have a horizontal shift left pi over 4. Okay, so let's think of our just function family here, nothing exciting going on. Pi over 2, negative pi over 2. Remember, this is where we had those vertical asymptotes. Now this is saying, hey, we're going to shift to the left, pi over 4. So instead of this going here, so let's say that's negative pi, we're going to go ahead and shift it here to negative 3/4 pi. Okay, and then now here's the tricky part too, is we are going to talk about the period only being 1/2 pi. So we're shifting this over But this is the period right here, right? It's a total, so this would be negative pi over 4. It's a total of 1/2 pi. Total of 1/2 pi. Okay. So we can see what's going to happen here is we're going to have another one here at pi over 4. And so we'll be able to, you know what? I need to redo this. This is not right the way I drew it. I'll tell you to cancel out watching part of that. Okay, sorry. Starting again. Okay. PB is pi. That is still correct. P is going to be times 2 equals pi. Okay. So 1/2 pi is still that